So we have a quantity called heat capacity. And when we say heat capacity, we mean the amount of heat needed to change the temperature of a particular amount of substance by 1 degree Celsius. Now, it says also in Kelvin. These particular calculations are the same for Kelvin and Celsius because they're not talking about a specific temperature, they're talking about a change in temperature. Yes?
Isn't heat capacity measured in BTU, right?
BTU is a unit of energy just like calories or joules. So it could be measured in BTUs, yes. BTUs are British thermal units. So heat capacity in chemistry is usually measured in joules or calories. But in engineering, I'm not an engineer, they do other stuff. If we express the amount of that substance in grams, because it's the amount of heat to change the temperature 1 degree, but if we have 2 drops of water or we have 2 gallons of water and we're trying to change the temperature, the 2 gallons is going to require more energy, right? Think of boiling water to make spaghetti. You've got a little tiny pot of water, or you've got a giant stock pot of water. You put them both on similar burners, crank up the heat the same. Which one requires more heat to get it to boil? The big pot of water, right? More water, more heat is needed to change the temperature. So the amount of heat needed to change the temperature depends on the amount of substance. Well, we find it convenient to measure that amount of substance in grams. And when we measure it in grams, then we call it the specific heat capacity, or sometimes we just call it specific heat. And then it has units of joules per gram per degree Celsius. So that looks weird. Joules per gram degree Celsius. And, weird units, but they're useful. Joules per gram degree Celsius. Or Kelvin, it's the same thing. So here's a table. You might need to look some of these up to do homework problems or examples from the text. I would never expect you to memorize these things. But here's some specific heat capacity of common substances. Here's water at the bottom. The specific heat capacity has the units of joules per gram degree Celsius. So water has a very high specific heat capacity, 4.184 joules per gram degree Celsius. Many of these substances here are metals, and they have very low heat capacities or specific heats. And here's ethanol, alcohol, that's kind of in the middle. But you might need to look some values up when doing homework.